Have you ever really thought about the numbers you use every single day? Well, guess what? They aren't just a random collection of symbols. They all belong to one huge, fascinating family, the real numbers. So today, let's get properly introduced.
I mean, think about it. You've got the number of episodes left in your favorite show, the temperature outside, a weird decimal from a math problem. How on earth do they all fit together? It turns out they have this surprisingly neat and tidy family tree, and we're going to climb it together.
So here's our roadmap for today. First, we'll get a bird's eye view of the whole number universe. Then, we'll look at the basic building blocks, the integers. After that, we'll see where the family tree splits in two with rationals and irrationals. We'll visualize the whole thing, talk about opposites and absolute value, and finally, learn how to put all these numbers in their proper place.
All right, let's dive right in. Think of this first part as looking at the big annual family reunion photo. Everyone's here.
You know, every big idea starts with some simple building blocks. And in the world of numbers, that foundation starts with the very first numbers we ever learn.
And here they are, the natural numbers. You might just call them the counting numbers. 1 cookie, 2 dogs, 3 seasons of a show. They're the most basic, intuitive numbers out there. They're positive, they're whole, and they just keep on going.
But what happens when you've eaten all the cookies? You have no cookies left. To talk about that, we need a new concept, 0. And when you add 0 to our group of natural numbers, bam, you get the whole numbers. It seems like a tiny addition, but trust me, it was a massive leap forward for math.
But what if you owe someone 3 cookies? For concepts like debt or temperatures below freezing, we need negative numbers. So take all the whole numbers and then add their mirror images, their opposites, on the other side of 0. Now you've got the integers. This gives us that beautiful symmetrical number line, stretching out to infinity in both directions.
So are you starting to see the pattern here? It's kind of like one of those Russian nesting dolls. Every natural number fits inside the set of whole numbers, and every whole number fits inside the set of integers. They just build on each other, getting bigger and more inclusive. This nested structure is absolutely key to understanding the whole family.
So far, so good, right? We've just been taking these nice, clean, whole steps along the number line. But what about all the little spaces in between those steps? This is where things get really, really interesting.
Exactly. What about half a cup of flour or a price like $9.99? Where do those guys fit into our family tree? Well, this question brings us to a huge split right down the middle of the number family.
Okay, so here's the family feud. On one side, you have the rational numbers. The key word there is ratio. If you can write a number as a fraction, it's rational. These are the predictable ones. Their decimals either stop nicely, like 1/2 is 0.5, or they repeat in a clean pattern, like 1/3 is 0.333. On the other side, you have the rebels, the irrational numbers. These guys just refuse to be pinned down as a simple fraction. Their decimals are pure chaos. They go on forever and ever with absolutely no repeating pattern.
And you've definitely met some of these famous rebels before. The square root of 2 is a classic example, and of course, there's the rock star of irrational numbers, pi. Its digits stretch out into infinity, never ever repeating.
So we have the orderly rationals and the wild irrationals, two totally different vibes. But when we bring both sides of the family together, we finally get the whole picture.
And this is it, the real numbers. It's the whole shebang. It's what you get when you take all the rational numbers and all the irrational numbers and put them together. Every single point you can possibly imagine on the number line is a real number. There are no gaps, no missing pieces. It's complete.
Okay, I think you've got it. Time for a little pop quiz. Let's take a look at these 6 numbers and see if we can figure out exactly where they belong in our number family.
All right, let's break this down together. First up, -3. That's a classic integer, right? And because it's an integer, it's also a rational number. Next, the square root of 25. Ah, a bit of a trick question. That's just 5, so it's a natural number. And remember, those nesting dolls, that means it's also a whole number, an integer, and rational. Okay, -7/2. It's written as a fraction, so it's a dead giveaway. It's rational. 0, that's our special friend in the whole numbers, which also makes it an integer and rational. 4.9, the decimal ends, so it's rational. And last, the negative square root of 3. Well, that's going to be a wild, non-repeating decimal, so it's irrational. And notice, every single one of these, no matter what else it is a real number.
Awesome. Now that we're pros at classifying numbers, let's look at a couple of really useful tools for working with them on the number line.
opposites and absolute value.
First up, the opposite. This one is super straightforward. A number's opposite is just its perfect reflection on the other side of 0. So the opposite of 10 is negative 10. The opposite of negative 50 is positive 50. Simple as that.
Next is absolute value. The best way to think about this is just one word, distance. Absolute value is a number's distance from 0 on the number line. And since you can't have a negative distance, the absolute value is always going to be positive, or 0. It's a really handy concept in the real world.
So let's find the absolute value of negative 8. First, we find negative 8 on our number line. Got it. Now we just ask ourselves, how many steps does it take to get from there back to 0? It takes exactly 8 steps. So, the absolute value of negative 8 is just 8.
Okay, we can identify numbers, we can find their distance from 0. The last piece of this puzzle is figuring out how they stack up against each other.
And you are going to love this because there is one simple, foolproof rule to remember. When you look at numbers on the number line, the number that's further to the right is always bigger. That's it. That's the whole rule. Let's use that rule on this list right here. Now, a little pro tip, it's usually easiest if you convert everything to a decimal first. So negative 5 over 2 becomes negative 2.5, and 3/4 becomes 0.75. Now we just plot them all on the number line, and you can see the order perfectly, reading from left to right, from least to greatest, negative 2.5, then negative 2, 0, 0.75, and the biggest is 1.5.
So there you have it, the entire family of real numbers, from the simplest little counting number all the way to the beautiful infinite chaos of pi. But what if I told you that this isn't the end of the story? What happens if you try to do something that seems impossible, like take the square root of a negative number? Well, that question opens a door to a whole other universe of complex numbers, where math gets really, really weird and wonderful. But that is a story for another time.